All right, so again, good afternoon, Thursday, May 2nd, and class from noon to 1. It's Math 123-03D. And today we're looking at section 17. It's called Polls and Margin of Error. And so let me just update you on our assignments. So WebWork 16 and Quiz 7 are due tomorrow. And then all we have left is WebWork 17, which is assigned today, and then the review quiz, the online review. And of course, you want to do that before you take your exam. It's your last chance to do awesome on your exam. Make sure you do that review quiz ahead of time and get 100% on it. And then look at the paper review. Again, the paper review that I posted is not for a grade. I posted the key with it, but that would be a good review to do also. This exam, it says here, exam 3 is a cumulative final exam over all 3 units. There are 10 multiple choice questions and 1 free response question from units 1 and 2. And then there are 18 questions that are a mix of multiple choice, short answer, and essay from unit 3, which is what we have just completed. So 29 questions, 120 minutes, and scientific calculator and scrap paper. And then the formula sheet that we've been using will also be made available to you. All right, so page 225 is where we're going to start today, and it's about polls and margin of error. And let's see, I was trying to find my glasses and I wasn't able to find them before class today. I have no idea what I did with them. And so I'm going to do my best here to read along with you. It says polls are used to gather information about a population. Often population sizes are too large to ask every individual person, so a sample of the population is asked instead. The population in a poll refers to all the people or objects whose properties are of interest. And the sample is a subset of the population, and that's what's used to represent the population in general. So the sample. When taking a poll, it is important to ensure that the sample is not biased, that is, favoring one outcome over another. The more types of people that are included in the poll, the less likely it is to be biased. So if it's not biased, that means it's fair. For example, if we were to take a poll about the possibility of raising taxes, we should make sure to include people of all tax brackets, not just the top 1% of earners. And so we're going to do this little exercise here with questions 1 and 2 that asks us to consider each sample and determine whether the resulting poll is fair or biased, and then explain why. So the first one says the school newspaper is gathering options about, or excuse me, let me try that again without my glasses here, right? The school newspaper is gathering opinions about average time spent on homework. A reporter sets up a table in the cafeteria and asks everyone who walks by how much time he or she spends completing homework. We want to know, is this fair or biased? Does it have just a random sampling of people, or is it only interviewing a certain group of people? What do you think? All right, so it looks like most of you are saying fair, and you're correct. So this is fair. I'm going to write this in here with you. Fair. And it's because since everyone needs to eat lunch, right, or everybody needs to go to the cafeteria for lunch at the school, then they're getting a variety of samples and viewpoints. So number 2 says, a student is weighing the pros and cons of creating additional playgrounds in the city. So she visits a playground near her home to gather opinions. So do you think this is fair or biased? Yeah, so great job, everybody. So this one is biased. My gosh. My handwriting there is worse than my second grader. Let's try that again. Of course, my second grader isn't usually writing with a mouse, right? Okay, that's a little bit better. Almost second grade level now. So this poll would be biased And think about it. If this person is looking at pros and cons of an additional playground in the city in general, then visiting only one playground where she lives isn't getting the whole gamut of opinions. It's only getting whatever socioeconomic people that live around her neighborhood think. It's not getting it from all the different areas of the city. So it is biased, yes. So if we flip over to page 226, we're going to look at a particular poll here and then answer some questions about it. So it says here, cell internet use 2013, nearly 2/3, 63% of cell phone owners now use their phone to go online. According to a new survey by the Pew Research Center's Internet and American Life Project, we call them cell internet users and define them as anyone who uses their cell phone to access the internet or use email. Because 91% of all Americans now own a cell phone, this means that 57% of all American adults are cell internet users. The population of cell owners who use their phone to go online has doubled since 2009. So it says here, it shows the graph from April 2009 to May of 2013. Source, Pew Internet and American Life Project Spring Tracking Survey from April 17 to May 19, 2013. It says N equals 2,076 cell phone owners, ages 18 and over. Interviews were conducted in English and Spanish and on landline and cell phones. The margin of error for results based on cell phone owners is plus or minus 2.4 percentage points. So it says here, where did this poll come from? It's really asking, who conducted the poll? So who conducted this poll? So the Pew Research Center, and it wants to know if it's fair. Did they randomly call people or did they target people? And yes, it is fair and random. Very good. So it wants to know what population is represented by the poll. Who? So this is the who question. Who was polled? Well, not okay. Yeah, there we go. Thanks, Alexandra. So cell phone owners, right? It was a question specifically if you own a cell phone. And 18 and over. Again, good. Thank you, Melissa. So these two components, whoops. So cell phone owners who are 18 and older. And then number 3 says not every adult American was asked about using the internet on their phone. Studies like this take a sample. What is the sample and how big is it? So again, the sample is this group of people, cell phone owners 18 and older, that's the sample. How big is the sample? That means how many people? So that N stands for the number of people, 2,076. So the questions we're asking is, who conducted the poll? Who was polled? How many people were polled? So those are some questions that we ask. Now there's a margin of error listed down here, 2.4 percentage points, plus or minus 2.4 percentage points. And I don't think margin of error is on your formula sheet, but I'll show you how to find it. So the margin of error is 1 over the square root of n, the number of people polled, times 100, and then you add a percent sign to the end of that. So like if I do this in my calculator right now, this is not the formula, but it's a good approximation, okay? It's a close approximation. When I did this, I got 2.2%, so it's plus or minus. So this formula here is pretty close to that 2.4 that they got. So they use a little bit different formula than I have for finding the margin of error, but this is a good approximation. So you can see that the larger number of people you have, the less amount of possible margin of error you're gonna experience. All right, so looking on page 277, we got two more questions here. It says, let's suppose another group of 2,076 American adults were asked the question, do you use your cell phone to go online? Would the percentage who said yes always be the same, or would it vary? Would you always get 63%? That's what the question is. So if you ask 2,076 other people, would you get 63% who said yes? And of course, no, we would not. That's what that sampling error is, that plus or minus 2%. So that means there's some kind of a range that you would probably get. So number 7 then says, suppose you could ask every American adult age 18 and older the question, do you use your cell phone to go online? Would the percentage who said yes be exactly 63%? Most of you are saying no. Well, I'm going to say it could be. Gosh, my mouse is not working very well with me this afternoon. It could be, but probably not. All right, so it could be 63%, but it probably isn't going to be. Because remember that 63% only came from those 2,076 people. If you interviewed, however many million, 200 million people or whatever it is that have a cell phone, it could be 63%, but it probably won't be. It'd be pretty close. So it says the idea that different samples of people polled will have different proportions of positive responses raises the question, how close to the actual population proportion is the reported 63%? So how close is that 63% to a result we would get if we were able to poll everybody? So it says here, polls should report a margin of error because of the possible variation in responses from sample to sample. The margin of error gives an approximation of how far off a sample's reported percentage might be. So the margin of error in the article was plus or minus 2%, or plus or minus 2.4%. And so we can define the range, and it says the range of values found by adding and subtracting, the range of values, is found by adding and subtracting the margin of error. And this is called a confidence interval. Confidence interval allows us to make statements about the entire population and not just the sample surveyed. So to use the margin of error, you add and subtract from the sample percentage reported. So for us, we're going to calculate the confidence interval. So we're going to do 63 plus 2.4 and 63 minus 2.4, and we'll get those percentages. So the first one looks like 60.6% to 65.4%. And so what that means is that we're pretty sure, and I'll make a more specific statement here in a minute, but that means we're pretty sure that if we ask the whole population, that somewhere between 60.6 and 65.4% of the people would say yes. So if we go to page 228, it says a margin of error also has a level of certainty associated with it, often 95%. This means if the same poll was repeated many times, we'd expect the outcome to be within the confidence interval 95% of the time. The level of certainty should be included in the statements that use the confidence interval. So here's an example. We are 95% confident that the true proportion of all cell owners that are cell internet users is between 60.6 and 65.4%. So there's 4 things in here that we have to make note of. So the first thing is we're going to state our confidence. We're 95% confident. And then we're going to say that the true proportion of all cell owners, so 95% confident, that if we interviewed everybody, then they would answer yes to the question, they're cell internet users, that percent of the time, or that percent of the time they'd fall within that range. 95% of the time, between 60.6 and 65.4% of the people would say yes. So it says the margin of error for these polls can be approximated in a number of ways. Each includes the sample size as part of the computation. Remember, the more people that are polled, the more likely the results are to be representative of the whole population. In other words, the more people that are in the study, the smaller the margin of error. So those components, when we make our statement, we want to include those components, okay? And we'll do that in this next example. We're going to look at this election survey from 2012. Okay, I'm going to stop there first though, and just see if we have any questions before I do this full example with all the questions involved that we've looked at so far. So what questions might you have? All right, so if you're being truthful and honest, we don't have any questions at this point. So let's look at this Gallup final election survey from 2012 on page 228. So it says on November 5th, 2012, Gallup published their final election survey results prior to the 2012 presidential election. The headline was Romney 49%, Obama 48%. And it says these results came from a telephone survey conducted with a random sample of 3,117 American adults living in all 50 states and the District of Columbia. Also included with the survey results is the statement, for results based on the total sample of national results, one can say with 95% confidence that the maximum margin of error is plus or minus 2 percentage points. So let's look at this poll, what we have here. We have likely voters, and in the likely voters, it looks like Romney Ryan was 49%, Obama Biden was 48%, other was 1%, and no opinion was 3%. And let's see, registered voters 46, 49, and 1 and 4. So I think we're going to look at the likely voters in this particular series of questions. So it says, was this poll accurate in its prediction of the 2012 presidential election winner, that Romney Ryan would win? No, it was not, because we know from history that Obama Biden won. Number 2 says, are predictions ever guaranteed? And explain. Are predictions ever guaranteed? Well, we know that the answer is no. So think about the prediction in terms of this poll. They interviewed 3,000 American adults. How many American adults are there? A lot, right? More than that. So thanks, Brian. You said more than that. You typed it as I was saying it. You're awesome. So, and Megan, perfect. You can't ask everyone, right? So, no, because it's just not able to be based on every person. On, that says based right there, BASED, on every person. Yeah, it's impossible to ask everybody. Even the census, when they come and do the census every 10 years, they don't get everybody. So number 3 says, use the margin of error in the likely voters line to calculate the confidence interval for these two sets of candidates. So remember, we had 49 plus or minus 2%. So that's going to be, what, 47 to 51. And this one was 48 plus or minus 2%, so 46 to 50. You see that there's some overlap there. Like here's 46, here's 50, 47 to 51. So all this in here is overlap. So you can't tell who the winner is going to be because they're within the margin of error of each other. So it says here, interpret the confidence interval for Obama-Biden in a meaningful sentence. Remember to include the margin of error provided is 95% certain. So I'm going to actually type this because it's way easier than writing with my mouse. So remember the components. Whoops, let me try that again. We're 95% confident that the true proportion of all likely voters, so there's the 95% confidence or 95% certain, there's the true proportion of all likely voters that would do what? That would vote for Obama-Biden. So there's part 3. Is somewhere between, what was that, 46 and 50%? So so there's the first part. Here's the second part. Here's the third part. And there's the fourth part. Okay, so we have these 4 parts that need to be included when we make our statement about one of these polls using the confidence interval. We're 95% confident, the true proportion of all likely voters. So the confidence level, who, what did they do, and what's the percent? How certain are we? About whom? What did they do? And what is that interval? And of course, you could put certain also if you wanted to. All right. All right, so let's wrap this lesson up with page 230. And this Teens Social Media and Technology Overview survey from 2015. So on page 230, find that in your book. And what I'm going to do here is I'm actually, let's see, is there anybody that does not have their book in front of them, or does anyone not have their book in front of them? I mean, it's okay if you don't. I just need to know. Who does not have their book in front of them? All right, you guys are absolutely amazing. So on page 230, what I'm going to do is I'm going to just start a timer here, and it is about 12:30. I'm going to give you guys about 5 minutes to come up with these 5 answers, 5 minutes or so. So I'm going to mute myself and give you about 5 minutes to do these 5 problems if you haven't done them yet. So if you would give me a hand raise when you're complete, and I realize some of you may already have this done, that's fine. But give me a hand raise when you have these 5 answers done. I'm going to take about 5 minutes here and wait for you, okay? Alrighty, well, it looks like most everybody is complete. So let's take a look here. Number one, it says, what population is represented by this poll? What is the population here? Yeah, we can just say teens age 13 to 17. And it says, what is the sample size? And that is 1,060 teens. So it says if the 95% margin of error is 3.0 plus or minus 3.07%, find the confidence interval for the population of teens who use Facebook. So the Facebook ones, I think, was 71%. We have to add and subtract. And you guys got it. You're awesome. 67.93% to 74.07%. And then write a statement interpreting the confidence interval. So I'm going to do that here again. So what can we say? We are 95% certain. Oh my gosh. Oh my goodness. That between, what do we say? 67. And if your statement is in a different order than mine, that's fine. So I wrote down, we are 95% certain that between 67.93 and 74.07% of all teens 13 to 17 years old use Facebook. All right, so good job, Brian. I see yours in the chat box. Yeah. So again, it's these four components. So that one, here's the range, who, all teens, and what did they do? So 4 components again. So make sure you have those 4 each time you make one of these statements. All right, and then the last question, can we conclusively say that teens use Tumblr more than different social media sites? And explain. So Tumblr, what are they at, 14%? Other is at 11%. So how can we tell here if we can conclusively say this, that teens use Tumblr more than the different social media? And the answer is no, we cannot. Because if you think about the range here, so I'm just going to add and subtract 3% rather than the 3.07. This goes from 11 to 17%. This one goes from 8 to 14%. So see how they overlap? So 8, 14, 11, 17. So all this overlap right here, they could be in that range. And so we don't know. So in that range from 11 to 14, Tumblr could be less than the others. And so that's why. So no, and this is the reasoning why, because of that overlap. Now, when you do your assignment, you're going to be asked some questions. Maybe it was in section 16, I don't know, but there were some questions that said find the percent. Oh, it must have been in section 16. I just want to make this statement here. So in section 16, there were some questions that might have said, like, it give you all this data, and it said, actually, give me just a second, I'll pull it up. Okay, give me just a second here. All right. So on one of the questions, it's probably section 17, looking at this, there's this table, and it says here that there were however many people that were interviewed, 6,224 Americans, and then they were asked these different questions. So one of the questions asks about students that were high school graduates, and only this many people, if you add those up, that's how many people answered the survey, not all 6,224 or whatever it was. So if it asks you what percent of high school grads, you have to take this number of high school grads and divide it by these four numbers added together, okay? Not the 6,224 that answered the whole survey. Only this many people answered the education attainment level, all right? So that's probably, it's probably going to be in section 17 since it goes with this data, okay? So there's just a note for you there, okay? All right. So we also have, well, are there any other questions on the polling and margins of error? All right, well, we have about 15 more minutes, and I want to share this with you. So this is I realize it says fall of 2018, but I posted it just as an extra review for you guys, and it's in your course. So it's in module 8 here. I'll show you where. And if you go to module 8, there we go. There's the review quiz, the online one that's required. And if you click on the next one, it has this practice exam. And then if you click next here, it has the key. So you have all the solutions. I wanted just to provide that for you as just some extra information, okay? But I do want to see if you have any questions about these ideas. So I just want to share with you a little bit here as kind of a review, just in case you're taking your exam before next Thursday. And so, and again, I would recommend that you don't wait until late on Friday to have it scheduled, because if something happens, you're not going to be able to take it, okay? So make sure you schedule it reasonably. And by the way, if you take your exam before our class next week, you don't need to show up for our class, because you'll already have done the exam. All right, you're welcome, Aaron. All right, good. So Melissa's going to have hers done Monday. So again, if you take your exam before Thursday, I will know if you took it or not, and then you won't be required to come to class. So if you take your test before class, awesome. Thanks for the awesome semester. I appreciated having you in here. All right. So, and then again, there's a student survey that you should complete about the course. It's like, was the material covered well enough, or was it clear? Things like that, about the course. So if you would complete that, that helps with everything, with how I present. It helps with the whole school as we make adjustments to the course. So if you could fill out that survey that came through your email, it's also in your Canvas notifications. I would appreciate that, and so would all of the other instructors. So as we look at this review, we can see the different types of topics here. I think there's 40 questions on this review, so there's a lot. Some of it some of it was from today and last week, so I'm not going to even look at that really. But this one is converting feet to miles, and you have that on your conversion sheet, right? 10 kilometers into miles. Make sure that you pay attention to the rounding. So make sure that when you take your exam next week, you round correctly, okay? How many centimeters are in a kilometer, pints to gallons. Let's see. So there's this one, 52-inch wide TV, has a screen area of 1,064 square inches. How many square feet is that? If you see any here that you want to look at, let me know, and we can look at them together here. That's why I'm kind of scrolling through these together. So number 6 wants to know which box has more cereal, the 2 foot by 1 foot by 8 inches, or the 18 centimeters by 12 centimeters by 14 centimeters. So, to do that one, you're going to have to find the cubic inches or the cubic centimeters, and then you can make the comparisons. You'll have to do some conversions there. So 7 is 20 quarts per minute. How many gallons per hour? So converting quarts into gallons and minutes into hours. 10 feet by 6 feet by 40 inches deep. What's the volume in cubic feet? So you have to change that. Oh, by the way, let me just show you this one. 10 feet by 6 feet by 40 inches. Whoa, 10 feet, 6 feet, 40 inches. Let me show you how to get a question like this correct. Okay, because some of you might be inclined to take 40 and divide it by 12. And the problem with that is you're going to get 3.33, and then where do you stop writing the threes? So what we should do is do 10 feet and use this factor label method times 6 feet times 40 inches, and then put our conversion in line, 12 inches in 1 foot. And you can see that we're going to have the inches cancel out, and we have feet, feet, feet. So we have cubic feet, which is what's asked for. And then we can go back and we can say, okay, can I reduce any of this? And you sure can. So 6, 12, and then we can do 40 divided by 2 is 20, and make that a 1 if you want, or you can just do it on your calculator. So this is easy to do in your head though. 10 times 1 times 20 is 200. So it's 200 cubic feet. So that's how I would recommend you do it, rather than using the decimals on your calculator, because if you use the decimals, it's not going to come out quite to 200 and you're going to get the answer wrong. So use the conversions in line, multiply and divide everything together. Don't do any rounding until the end. That's kind of the rule, is never round until you are at the very end. So you could have done 10 times 6 times 40 divided by 12, and you would get 200 also. But if you do the 40 divided by 12 first and you get 3.33, and then you start multiplying by 10 and 6, then you're going to get some decimal, and it's not going to quite be 200. So look at number 9, 10, and 11. See if you have any questions there. And again, as you review for your test, you have the online one that's required, and then these are just extra. But you have the solutions to all of these, so you can go, oh yeah, that's how I did that. I remember now. So this one here, number 13, is calculating that range for the 68, 95, and 99.7%. That's the normal distribution. So you add and subtract the standard deviation once for A, twice for B, and 3 times for C. So be careful when you do your exam. You know which one you're looking to find. So number 11. Let's see number 11. So number 11 says if your car gets 24 miles per gallon and you drive 420 miles, how many gallons of gas are needed on the trip? And then how many pounds of CO2 would you need? And so if we look at this one, we have to find out how many gallons. So we have to start with the 420 miles. Let's see, 24 miles per gallon. Let me get my other sheet here. So 24 miles per gallon. If we write it like this, the problem is gallons is going to be in the denominator. So we need to do 1 gallon every 24 miles. And then times 420 miles. I think that's how many miles it was. I have to look. 420 miles, yes, okay. And then we're going to multiply by that 19.8, so the miles cancel out. Then we have that 19.8 pounds of CO2 per gallon. And so we can see that the gallons are going to cancel out next. And we're left with just pounds of CO2. And so we can multiply it all out. So 420 times 19.8 and then divided by 24. And that's approximately 47, let's see, 347 pounds of CO2, approximately. So there's number 11, Melissa. Number 15, remember this, we're using electricity this time. It's at 1.37 pounds of CO2 per kilowatt hour. So on something like number 15, and I'll go back and do number 3, okay? On number 15, we have the 340, and remember, I want to show you this too. So 3 hours, 340. Let's do a new page here. So 340 watts. We have to change that into kilowatts, remember. And then we have the hours, 3 hours, and then the 1.37 pounds of CO2 per kilowatt an hour. And then notice again how the watts are going to cancel, the kilowatts are going to cancel, the hours are going to cancel, and we're left with just the pounds of CO2. And then multiply that out. Okay, so Brian wanted to see number 3. Let me scroll back up there. How many centimeters are in a kilometer? That's a great question. So remember, kilometer, hectometer, decameter, meter, decimeter, centimeter, millimeter. So how many kilometers, wait, let me read that question again. How many centimeters are in 1 kilometer? So we look at this and we go, how many places do we have to move that decimal? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So there are 100,000 centimeters in a kilometer. Remember, there's 1,000 meters in a kilometer, 1,000 meters. So there's 100 centimeters in each meter. So that's why it's 100,000. All right, so I gotta watch my time here. We have about 2 minutes left of recording time. So remember z-scores. So doing these tables to find your probabilities, watch out for the word if. Remember those conditional probabilities, like if the alpaca is white, that denotes the denominator, remember. And then megaesophagus, this choking disease that alpacas have. This is what we did last week with the false positives and false negatives. The customer wait times, we did that. That's what we did today. Don't forget you have the dosage calculations. That would be an important one to look at. Dosage calculations. And let's see, I want to make sure I reminded you of this. So don't forget how to calculate a GPA and a weighted average. All right. So there's lots of things here. Proportions, make sure you go over proportions. Spend some time looking at all these ideas, please. So Stephanie asks about number 18. Yeah, the problem I have here is that this is a PDF, so I can't actually type in it. But let's take a look. So just of where numbers would go. So down in the bottom right is where the 1,000 would be. It says 4% have this disease. Let me see if I can draw this. Have the disease, don't have the disease, positive test, negative test, and then the totals. So it says there are 1,000 of these animals. 4% have the disease, so that means that 40 out of those 100 have it. So 960 don't have it. That's how we would start. And then, let's see, I gotta read the rest of it here. It's 90% accurate. That means that 90% of the time it's gonna be right, so they're gonna have it and they're gonna have this positive result. So 90% here and here, 10% in those two spots. So this is going to be 4 and 36, 96 and 864. And then we're just going to add down. This is 868. Make sure that these add up to 1,000, 132. And then we can answer our questions. So there's how we fill out the table and then answering the questions. So it says here, if an alpaca tests positive, what is the probability it has the disease? So this is a conditional probability. If they test positive, that's our denominator. What's the probability that they have the disease? So they have it, 36 out of 132. And let me grab my handy dandy calculator. 36 out of 132 looks like about 27%. Let me see if it wants us to round it anywhere. Round to the nearest tenth of a percent. So 27.3. That's the first one. And then part B says, if an alpaca tests positive, what is the probability it does not have the disease? So we can just do 100% minus that. So that's going to be 72.7%. Or you could do the 96 over 132. You would get the same result. And that is the false positive. Remember, the test says it's true, but they don't actually have it. So that's the false positive, 72%. That's a lot, isn't it? And then part D says if an alpaca tests negative, what's the probability it does have the disease? So this is the false negative. So if it tests negative, so that's our denominator, 868, what is the probability it does have the disease? So it's 4 out of 868. So 5%, and that is the false negative. So the test showed negative, but they actually have it. For part D. All right, was that a little bit helpful, Stephanie? I know it was kind of quick. All right, well, I'm going to end the recording there, and if you have questions, we can stick around and do those. Again, if you haven't scheduled your exam, I don't know if you're going to be able to, but good luck, okay?